Today, we will be talking about how to sketch a trigonometric graph functions and how it is derived. Firstly, we will be talking about the sine graph in radian mode. This includes pi over 2, pi, 3 pi, and 2 pi. A standard sine graph consists of two intersections, also known as the solutions, one maximum and one minimum point. The sine graph starts from 0 and increases to 1. When it reaches 1, it is 1 unit above pi over 2. This is also known as the maximum point. After the maximum point, it continues to decrease and intersect at pi until it reaches -1, which is 1 unit below 3 pi over 2. This is known as the minimum point. Lastly, in order to have a full cycle, the graph increases from the minimum point to 2 pi, and that is the end of one cycle. Next, if we advance the basic sine graph to 4 sine bracket x plus pi bracket, we have to find the amplitude, period, phase shift, and frequency. In this case, the amplitude is the first term of the graph, which is 4. Next, the period, which shows how far can the graph stretch in one cycle. We use the formula 2 pi over b, where b is with the product of x, which is 1, and we will get 2 pi. Whereas, to find frequency, we use the formula b over 2 pi, whereby we flip the numerator and denominator, and we will get 1 over 2 pi. Lastly, in order to find the phase shift, we can use the formula negative c over b, whereby b is 1, the product with x, and c is 2 pi, and we will get negative pi. Otherwise, we can set the terms in the bracket equals to 0 to find the phase shift. After finding the point, we can draw a basic sine graph as a reference. Let's draw the basic sine graph. After drawing the basic sine graph, the graph, which includes the maximum point and minimum point, will shift pi units to the left in order to have a full cycle. The reason why it is pi units to the left is because it's negative pi. And therefore, we will be able to achieve the graph that we want. Next, we will be talking about the cosine graph in radian mode. Similarly, a standard cosine graph also consists of two intersections on the x-axis, also known as the solutions. At the same time, on the x-axis, there is pi over 2, pi, 3 pi over 2, and 2 pi. So let's draw the x and y axis. After drawing the axes, the graph will also include one maximum and one minimum point. Unlike the sine graph, cosine graph starts at 1. This is known as the first maximum point, after which it decreases to -1, intersecting the x-axis at pi over 2. When it reaches to -1, it is 1 unit below pi. This is known as the minimum point. The graph will then proceed to increase and intersect at the x-axis at 3 pi over 2 until it reaches 1, leaving it 1 unit above 2 pi. This is thus known as the second maximum point. This is, therefore, a complete cosine graph. Previously, in the graphs 4 sine bracket x plus pi bracket,
we did mention how to find the amplitude, period, frequency, and phase change. As such, in this graph, the amplitude will be 4, period will be 2 pi over 2, which is 2 pi. Frequency will be 1 over 2 pi, and phase change will be negative pi by using method 1 and method 2. After finding the unknowns, we can now sketch the x and y axis. Firstly, as usual, we can draw a reference graph. We can draw cosine bracket x plus pi bracket as a reference graph, whereby the graph from negative 4, which is the minimum. Next, it will increase diagonally and intersect at pi over 2 until it is 4 units above pi. This is known as the maximum point. In order to complete the cycle, the graph decreases diagonally, intersecting at 3 pi over 2 and continuing until it is 4 units above 2 pi. Lastly, with the values that we have found, we know that the phase shift is negative pi, which means the entire graph of the basic cosine graph, cosine bracket x plus pi bracket, will shift pi units to the left, and the graph is sketched and complete.